Hello and welcome back to this series on topic modeling and text classification for the purposes of the digital humanities. Now, in the last video, we looked at Gensim and Jupyter Notebook very quickly. In this video, we're going to start implementing LDA, or latent dialect allocation, topic modeling in Python using Gensim, and for the purposes of visualizing the data, we're going to be using Jupyter Notebook in this instance. And I'll be making this Jupyter Notebook live, and as promised, we're also going to do live coding. So what I want to do is just kind of jump right in. The first thing that you're going to want to execute, if you haven't done so already, is you want to pip install Nltk, spelt like that, Nltk. This is the natural language toolkit, and we're going to be using it mainly just for its stop words. So you're going to want to import Nltk. It helps if you're actually using a code section, not a markdown section. You're going to import Nltk. And then you're going to also want to run nltk.download, and you're going to want to download stop words. Execute that command, and NLTK will automatically download a list of stop words for different languages that you can then utilize to kind of automate the removal of stop words in your Python script. So go ahead and run that. Now we're going to import the libraries that we're going to be actually working with throughout this script. So we're going to import NumPy as NP. This is pretty standard. NumPy is a way of basically taking data and making it more efficiently stored in memory as numerical arrays. We'll talk about that in just a little bit. We're going to import JSON. We're going to import glob. This is going to allow us to work with multiple texts and JSON files in Python. And if you're not comfortable with JSON, I encourage you to get comfortable with it because it is a very important way of working with data in Python and just generally. And now we're going to import all the stuff that we're going to be using from the Gensim libraries. We're going to import Gensim. We're going to do, import Gensim.corpora as corpora. This is going to be how we work with our textual data. And we're going to also import from Gensim.utils, we're going to import simple pre-process. This is going to be very instrumental later in the script when we need to pre-process our data, so kind of cleaning it so that it can be processed by Gensim. This is going to save us a lot of time from writing out long code to do this manually. Next, we're going to do it from Gensim. We're going to be doing Gensim.models. We're going to go into that models, and we're going to import coherence. Coherence model with a capital C and a capital M. Next, we're going to need to import the stuff that we're going to use from Spacy. We're going to mainly use Spacy for its lemmatization purposes. So we're going to import Spacy, and then we're going to also right here import, from nltk.corpus import stop words. So we're going to import those stop words that we downloaded if you ran that nltk download stop words script that I told you just about a second ago. And finally, we're going to need to import some stuff for visualizing the data. And here we're going to use the library PyLDA viz. And I do not know of a better way to visualize LDA models in Python beyond PyLDA viz. It's absolutely outstanding. If you have a suggestion, please let me know in the comments down below because I would really enjoy to hear it. And we're going to do import PyLDA viz.gensim, so we can actually it's really great. It's built to work efficiently with Gensim so that you only have to run 3 lines of code and you can get these outstanding visualizations, which we actually saw in the first video in the series. And finally, this is mainly just for me. I have a problem with Jupyter Notebook in my environment right now, and I'm not really sure what it is, but I am getting a whole bunch of warnings that are not necessary. So I am running this mainly for myself right now. And category is going to be equal to depreciation warning. And a good rule of thumb is to always just run a cell when you actually are doing this. So you can see if you have any errors from your importing. And it looks like we're getting an error thrown right now. It looks like I've not added an S after models. This just kind of prevents some little mistakes from later on. From nltk.corpus, not really sure what's going on there. From nltk.corpus, import stop words. Oh, I misspelled NLTK. There we are. NLTK. And of course, there's another another problem here. Category depreciation warning not defined. I probably just misspelled it. And now let's go ahead up here. Restart. There we go. Okay. Now everything's run correctly. I have this written out because I add this in all of my scripts. It's a way of simply loading in and writing JSON data really efficiently with just one line of code later on. Go ahead and spend time and just kind of write this out. I'm going to kind of just jump ahead and move forward though with the actual preparing of the data now. So I'm going to execute this as well, and now just kind of move forward. So what we need to do first, very first thing, is create our stop words. So we're going to create the stop words by grabbing those stop words that we imported a second ago from Nltk. And we do it by doing stop words.words, and we pass in one argument, which is going to be the language that we want to actually grab. And now we have a list of stop words. And you can actually print them off and see what they look like right here. So these are all the stop words that you would have in English, and notice that they've all been lowercase because this is a necessary step in preparing a topic model, is to lowercase your data to minimize the quantity of different words that are represented by it. So if you want to, take a moment, read through this if you want to. These are a pretty standard stop word list. Next, what we want to do is we want to actually load in our data. So let's do that right here. We're going to do data is equal to load data. So I'm calling in the JSON function that I have right here. And we're going to pass in one argument here. This load data is going to be the string in which our data is found. For us, it's under data /USHMM _dn.json. And this is actually going to be a collection of a dictionary of two different keys, one with the RG number, which is the ID number, and the second with texts. So I'm going to grab texts, and then what I'm going to do is I'm going to print off data 0, and we're going to just grab the first 90 characters from that so you can see what it looks like. So here's the example of the testimony. It's just the start of the first sentence. And there you have it. This is the start of the actual oral testimony. So let's start off with some basic other pre-processing methods that we can do in Python. And for this, we're going to harness the power and leverage it from the spaCy library. To do this, let's create a function called lemmatization. Lemmatization is the reduction of words to their root form, essentially their lemma. There's different ways of doing lemmatization. We're going to be using spaCy. You can also use Nltk's method of grabbing the root of a word. These are a little bit different, and I'm not going to get into the differences right now. We're going to create a few different arguments. The first thing we're going to pass are the texts. So what we're going to try to do is iterate across all of our texts and essentially lemmatize them, reduce them to their core root words. The other thing that we're going to pass are the allowed post tags, and we're going to make this equal to a list. Now, I like to have this argument here because it means that I can make adjustments based on, as you'll see, parts of speech. So let's say I only am interested in including nouns, adjectives, these are the spaCy ways of representing them, verbs, and adverbs. I've done this already, and I know that this results in fairly good results when we get to the end of this series on LDA topic modeling. So I'm going to stick with these 4 parts of speech right now, and you'll see how they come into play in just a second. The next thing we need to do is we need to create our spaCy object. If you're not comfortable with spaCy, I have a whole series on spaCy 2.0, and that's the syntax that I'm using here. I plan on upgrading this Jupyter notebook in the near future to spaCy 3.0. But while people make the transition, I'm keeping everything in 2.0 just so it has wider applicability. So we're going to do spaCy.load, and we're going to load in the en core web sm, the small model. If you've seen my spaCy series and my NER series, you're more than comfortable with this syntax. If you're not, I highly encourage you to go and look at the spaCy series, at least to understand what's happening here. In just a few videos, you'll be able to really understand what's going on. What we're going to do is we're going to disable a few different things. We're going to disable the parser, and we're going to disable the NER. These are computationally more expensive and not necessary, and it's going to allow this script to run a little bit more quickly. Next, we're going to create a texts out object, and this is going to be an empty list. Now, there's more efficient ways to do what I'm about to do, but I'm going to write it out in longer code so that it's more legible to an audience that might not be as comfortable with concatenating lists. So we're going to say for text in texts, so we're going to iterate over the text objects that are passed to it. In other words, each of the 250 or so oral testimonies, and we're going to say doc is equal to NLP text. And that's going to create a doc object that's going to contain a lot of essential metadata about the information. And we're going to create another object. It's an empty list called new text. And now we're going to iterate for token in doc. So we're going to iterate over each of the words in the doc object, each of the words in that text. And what we're going to say is if the token dot part of speech is in our allowed post tags, so if it's a noun, an adjective, a verb, or an adverb, then what we want to do is new text.append token.lemma underscore. And the lemma is going to be the lemmatized form. So if the word is any of these things, we want it to be appended, but we want to not append the word, but the lemma itself. And what that does is it reduces the complexity of the text and by having fewer words in it. And it allows for topic models in general to harmonize better on the data and have better results. And it has the added benefit of being computationally less expensive. So finally, what we're going to do is we're going to reconstitute those lemmas into a text once again, and we're going to join it up as, helps if I spell correctly, new underscore text. And then we are going to simply do texts out.append final. If you're really comfortable with Python and you're looking at my code right now, you're probably going to have realized that there was a faster way to do this. But like I said, this is geared towards a larger audience than experts. So finally, we're going to return texts out. And what this function will do, let's just go ahead and demonstrate it. It'll allow us to pass in essentially a single text or all of our texts and get a lemmatized version. Now, this is going to take a second when I call it. So I'm going to pause the video after I execute the code, and I'll pop back once it's finished running. So we're going to call in all of our data, so all of that textual data. And then what I'm going to do is I'm going to print lemmatized texts, and I'm going to print off 0, 0, and I'm going to grab the first 90 characters once again. And we're going to see how radically different this is in just a second. So I'm running it, and we'll pop back when that's done, because it'll take about 2 to 5 minutes, maybe 10 if you're running on a slower computer. And now we're back, and as you can tell, the lemmatization function has run, and we get something that looks almost incomprehensible to the human eye. Name bear, small town, call bear, very hard work. And I know what you're thinking, why is this saying bear? It's because it's the lemmatized form of the word born. And even though this makes less sense to us as humans, it's going to allow a topic model to categorize things a bit more easily. And we're going to see that in action in just a second. Before we get down to actually creating the topic model, we need to do one other step. We haven't prepared the data adequately enough for processing in LDA topic models. So to do that, what we're going to do is we are going to create another function. We're going to call this gen words. And what we're going to do is try to reduce these texts to individual words and remove stop words, essentially. So we're going to pass in an argument of the texts. And this will be a little quicker to run. We're going to make an empty list called final that we're going to append to for text and texts. So we're going to iterate over all of those texts. We're going to say new is equal to gensim.utils.simple preprocess. We're going to pass in the text, and we're going to pass in another argument of deac. Deac stands for deaccent. It's a Boolean, true or false. I think by default it's false. I'm making it true here because I know that in my documents I've got some Polish words and some German words that may contain accent marks. And just in case, I want to make sure that they are all normalized to reduce the complexity once again of the model. So reduce everything to the core essential letters of the Latin script. So we're going to finally do final.append new, and we're going to return final. And so what you'll get is a lemmatized and text broken down now by individual words. So let's see what this looks like. We're going to print data. Oh, sorry, we're going to print, actually what we're going to, we have to make the object first. We're going to create data words, and that's going to be equal to gen words, and we're going to pass in our argument from up here, our lemmatized texts. And now to see what that looks like, we can print off data words. And again, we're going to print off the first index, so 0. We're going to grab the first text, and we're going to print off just the first 20 words. Let's see what that looks like now when we run this. And here we have stop words removed, and really just a much cleaner text finally. So with this information, we can now use it to actually start creating our LDA topic model in just a second. But first, before we do that, it's really good to have what we call an ID to word dictionary. And we're going to create this by saying ID to word. This is the conventional way of doing it. Corpora.dictionary. So we're going to go into that corpora part of the Gensim library, and we're going to pass in data words. And what this is going to do is it's going to allow us to actually have a few different key pieces of data. And you'll see that in just a second. Let's create an empty list right now called corpus. We're going to say for text and data words, so we're going to iterate over each of the texts in there. We're going to say new is going to be equal to id to word dot doc to BOW, which stands for bag of words, text. And what this is going to allow us to do is essentially create a bag of words that's going to contain a couple different things that we'll see in just a sec. It's going to contain a list of unique words and their frequency in the corpus. So what we can do now is once we run this, we can print off corpus 0. So we're going to grab that first document again and 0.20. And this is going to be pretty cool. Let's run this and see what it looks like. Well, what we see here is something that is now totally illegible to us humans, but perfectly legible to a computer, and in fact, more so. We have a list now of not just words, but tuples. And believe it or not, this is the same exact information that we had before with one added component. So let's take a look at an individual tuple, 0 and 2. So this is the first index right here. 0 and 2, what could that possibly mean? Well, 0 corresponds to the index of the word in our dictionary. We'll see what this word is in just a second. The other item is the actual frequency of that word. To demonstrate this, let's do this right now. Let's say word is equal to, and we're going to make this equal to ID to word, and we're going to make it equal, we're going to grab specifically text 1. So we're going to grab that. This will grab that first tuple for us. And let's print off word. And you'll see that it actually corresponds to the word able. So now we have essentially a great dictionary for looking up words and their frequency. But now comes the fun part, actually creating our LDA topic model. This is what we have done all this work to actually achieve. And we're going to be able to do this in one line of code. So we're going to call this LDA underscore model. That's the typical way in which you would do it. Gensim.models.LDA model.L capital this time, DA capital M model. And this is going to take a bunch of different arguments. I'm going to provide a link in the description down below for all the different ones that you can actually pass here. For right now, though, we're going to just kind of use a few of them. So the first thing we're going to do is we're going to pass in the argument of corpus, and that's going to be equal to, you guessed it, our corpus. Next, we're going to take and have an argument of ID to word, and you guessed it, this is going to be equal to our ID to word. And next, we're going to say the number of topics that we want to do. I'm going to select 30 right now, and I know for a fact that this is way too many, but you're going to see a lot in the mistake chosen here for 30. And this is going to lead into our next video when we start to actually adjust the LDA model and adjust some of our pre-processing to have a better result based on the results that we see from this initial pass. So we're going to say 30 there. Like I said, that's wrong. state is going to be equal to 100. And I'm not going to go over all these parameters. There's a lot to go over. I think that this can take up to like 30 or so of them. Check out the description down below and you can see what each one of these actually does. Update every one. So it's going to update essentially the topic model after each iteration. Chunk size, make that equal to 100. And passes, we're going to pass over the data 10 times. Alpha, we're going to make that equal to auto. And what we have here now is everything that you need to actually have a topic model. So I'm going to create a few extra cells real fast. Invalid syntax. Oh, I forgot commas. Foolish, foolish me. I was talking and not actually writing things correctly. There we go. And now what we're doing is we're generating a topic model. This is going to be a little fun to actually see. It's not going to take too long because we're not working with a giant corpus. It should be done in just a second. While that's running, let's go ahead and, oh, it's already done. Let's start working on how we're going to visualize this data. So we've got the topic model sitting in memory right now, fully trained. Believe it or not, that's all it took. So what we can do now is actually start to analyze the results that we're looking at. To do that, we'll want to actually do a couple different things. The first thing that we want to do is use that Py LDA viz library. And we're going to want to use enable notebook. That's going to allow us to run this in line here. So we can actually see the visualization in Jupyter. Viz is going to be equal to Py LDA viz.gensim.prepare. This is why this library is particularly well suited for this problem, because this will allow us to actually just work off of everything we've done in Gensim. And so we're going to pass in the model, the corpus, the ID 2 words, that dictionary, so it can look things up. MDS is going to be equal to MMDS. And there's a couple different arguments you can pass here. I'll get into that in a later video. R is going to be equal to 30. And now what we need to do is we need to just simply call it, and we can actually see what we've already, what all of our work up until this moment has achieved, which is going to be a nice visualization of our topic model. I'm going to zoom out just a little bit so you can see. So what are we looking at here? Well, we're looking at a really big problem. We're looking at, remember, we called for 30 clusters, and we only are looking at, it looks like 9, which means our data is, the way we pre-processed it and the number of topics that we are seeing is wrong. In addition to that, we're seeing a high concentration of clusters, a lot of overlap between these ones right here. Each one of these circles represents a different topic or a different cluster on the graph. And if you're looking at it, you'll see the top words associated with that cluster on the right-hand side. The top 30, this is what the R argument's for, the top 30 words. And if you're looking at this and you're looking at the words, I'm not seeing words that are really particularly good at harmonizing topics. I'm seeing things like go, very, would, just. I'm not seeing stuff that's making these topics unique enough. And so when I'm looking at these results real quickly, I think to myself, okay, I've got a few words that aren't really doing much here. And so what I want to do right now real fast is go back and kind of think about how we can take these words that we're seeing frequently that don't actually contain a lot of meaning, words like would, go, no, say, come, and create essentially a removal list. And this removal list will then serve in the next video to start making some adjustments to our code, some adjustments to our pre-processing to get these documents and these topics to harmonize a bit better. In other words, we're going to force clustering to take place by controlling, essentially in creating a custom stop word removal list. And we're going to see that in the next video. Hopefully now, though, you have the basic code that you need to pre-process your data on a basic level and produce an LDA topic model and visualize that model. If that's what you've learned from this video, then mission accomplished. In the next video, we're going to start working on having better results.